Okay, so hopefully that one seems pretty straightforward. Let's move on. The fourth question is asking, how many pounds of urea, which is a 4600, need to be used to apply a tenth of a pound, 0.1 pounds of N per 1,000 square feet to 2.7 acres of putting greens at Hawks Nest Golf Course. So this is a perfect example of the concept known as spoon feeding. And so our rate in this example is going to be 0.1 pounds of N per 1,000 square feet. Okay? And the analysis of fertilizer that we're using is urea has an analysis of a 4600. So there's no phosphorus and potassium in urea, and it's soluble. So you're going to learn some of these fertilizers that we talk about in class can be applied granularly, or they can actually be dumped into the spray tank and get in a solution. And that's really what we're doing here. You would never use urea to apply 0.1 pounds of N per 1,000 square feet, and I'll show you why in a second. And so we're going to apply this actually using the sprayer, but the way you'll do the calculation is pretty much the same, to 2.7 acres. So let's just walk through this. So again, I want to know how much product. I want to know how many pounds. How many pounds of urea. Okay, so again, rate over analysis, or what you want over what you got. We want a tenth of a pound, and we've got a product that's 46% nitrogen, and so 0.1 divided by 0.46, it's going to give us 0.217 pounds of urea per 1,000 square feet. So think about that. If you can picture 1,000 square foot section and only applying 0.2 of a pound of product, that's very, very little. Okay, and this is why you don't see urea typically applied as a straight fertilizer. When it's being used, a lot of times it's going to be used in a sprayer and broken down, or it's going to be watered down to where it won't be such a high analysis. And so we now know how many pounds we need per 1,000 square feet. We've got 2.7 acres. So again, let's convert this into pounds per acre. So I'm going to multiply that by 43.56. And we're going to get 9.47 pounds of urea per acre. And we're going to apply it to 2.7 acres. So we're going to need a total of 25.56 pounds of urea. Okay? So real quick, we haven't got into rates yet in this class, but that's exactly where we're headed next. This is what's known as a spoon feeding rate. This tenth of a pound is the kind of application that would be made every 10 to 14 days. So instead of going and saying, hey, I'm going to make an application in the spring and the fall and that's it, you're going to see these highly maintained surfaces like putting greens, sports fields, even fairways, tees, that they're, instead of getting a few large applications, they get this real spoon feeding approach to where they're getting frequent applications at a low rate. And we'll get into why that's advantageous. It gives you the ability to kind of control the growth where you're just applying what you need. You're not applying too much to where you stimulate all this excess growth, but you can kind of keep things really dialed in. So, so this equation here, this format is not necessarily being done because you want to go spread this with a spreader. It's actually being done to where we're getting the material to then dump into a sprayer. And so you're going to see that this is all going to build as we work through this class. So let's do the last one. Okay, this is a unique question. So number 5, if a 50-pound bag of a 2300 costs $21 a bag, and a 40-pound bag of 1800 costs $16 a bag, then what is the cost of the pounds of N for each product and which is a better deal. So this is an example where you've got these two different products and you're trying to actually determine, well, which one of them am I paying more for? It's almost like if you've ever been to the store and you're looking at like, okay, here's the jumbo thing of toilet paper with 50 rolls and here's the regular one with 20 rolls. And you start to look at the prices and you go, well, what am I paying actually price per roll? And sometimes you see that like, oh yeah, the 50 one is a lot cheaper, but a lot of times you see like, oh, it's really, it's pretty much the same price or really not that much more, not that much cheaper. So that's what we're looking to do here with a question like this. We're actually trying to figure out, okay, on the per unit of nitrogen, what am I actually paying? Because you may determine like, oh, I'm going to go with a different product because I'm actually getting more bang for my buck. So let's just call this one Fertilizer A, and this is a 50-pound bag, and the analysis on this is a 2300, and this one costs $21 per bag. So this would be a relatively cheap fertilizer. We have bags of fertilizer that get up in the $40, $50, $60 range for the real high-end stuff, but this would probably be a pretty basic fertilizer you might see used in a kind of residential lawn care scenario. So that's Fertilizer A. And let's put Fert B down here. Fert B comes in 40-pound bags. You might think, oh, that's very nice, but you'll see that's how it is. Anderson's sells a lot of their fertilizers in 40-pound bags, while others do it in 50-pound bags. So don't always assume that it's going to be 50 pounds. This has an analysis of 1800, and it costs $16 per bag. So, I mean, you could just say, oh, well, let's figure out, how much we're paying per pound. We're not really interested in that because if this fertilizer, was a really low analysis, it really wouldn't be a fair comparison. So we want to work it out to figure out what is the actual cost per pound of nitrogen. So let's work through that. First, I want to determine how many pounds of nitrogen are in each of my bags. So that first question like we did before. So if we have a 50 pounds of fert, I know that for every pound of fert, I'm going to have 0.23 pounds of N. So 50 times 0.23. I know for Fertilizer A, in every 50-pound bag, I have 11.5 pounds of N. Coming down to Fert B, 40 pounds of fertilizer. And this has an analysis. We have 0.18 pounds of N for every 1 pound of fert. So 40 times 0.18, 7.2 pounds of N per bag. Okay, so let's actually try to get this worked out. So we know for every bag, we're paying $21 for every bag, right? And we know that in every bag, we have 11.5 pounds of nitrogen. Okay, so really all we're going to do is 21 divided by 11.5. And for this we get an amount of, we're paying $1, looks like about $1.83 per pound of nitrogen. So that's for Fert A. And if we come down here, we see that we're paying $16 per bag, right? And in each bag, we have 7.2 pounds of nitrogen. So 16 divided by 7.2 gives us $2.22 per pound of N. So you can see Fertilizer A, we're paying about 40 cents less per pound of nitrogen than we are for Fertilizer B. So Fertilizer A is actually a better deal, even though it looks like the price per bag is more. The fact that it's a little higher analysis and a little bit more, we end up seeing that Fertilizer A is the better deal. So, this is this is the start for these questions. From here, we're going to build on actually the fertilizer calibration and how that goes. And then we'll start to work out into some of the different elements, into the phosphorus and the potassium. And again, I start with nitrogen because it doesn't have this caveat of having oxidized forms of the mineral elements. So hopefully that helps. Again, in the modules tab, you're going to see the other worksheet. It has 10 questions on it. It's worth 10 points. I really don't see it taking you guys all that long. I'd be surprised if it took many of you more than 30 minutes to do. But please take your time. Make sure you get those right. Some of you guys, looks like the quiz got a few of you. These are really nice kind of freebie points that hopefully you can take your time and get them right. So good luck, and I will see you guys on Monday.